Hello, everyone. Thank you for attending the final symposium for Cohort B of the CDAC Data and Computing Summer Lab. My name is Julio Ramirez, and I'm fortunate to have worked as a research assistant this summer with Professors Blase Ur and Feamster. During the past 10 weeks, I worked on two different projects in the SUPERGroup Research Lab. The first project focused on fairness in machine learning and helping people to better understand potential issues with data that they use while training a machine learning model. I also worked on a project on the Internet of Things to help better protect smart devices while ensuring devices remain as functional as possible. For this presentation, I will discuss my work on the Internet of Things, part of the SmartWall project. While devices such as smart speakers, smart plugs, or even smart lights may be useful for productivity, saving energy, and improving aesthetics in a home, they present privacy and security issues. Devices such as those mentioned sometimes only come equipped with minimal measures for authentication and encrypting network traffic that comes from these devices. This lack of security makes smart devices vulnerable to outside attacks that can prevent them from working normally and require more measures to mitigate these threats. However, it's a challenge to find a one-size-fits-all solution for environments that contain different products created by different manufacturers. However, there is a way to fix it. A solution to this is SmartWall, a system that generates firewall rules that can be implemented onto devices with limited interruption of their regular functionality. It was developed using data collected from IoT Inspector, software that monitors network activity of smart devices connected to a network. The data used consisted of network traffic from more than 6,000 smart devices. To determine whether rules generated by the system work in a real-world scenario, I turned my family's apartment into a smart home. I installed 10 devices throughout my home, devices also found in the dataset used. As you can see on the screen, these included a Google Home Mini, a SmartThings smart plug, and a smart light bulb and light strip connected to a Philips Hue bridge. I also set up a Jetson Nano, a small computer board similar to a Raspberry Pi, to collect packet captures using Wireshark. The smart devices I installed were connected to a separate network using a different router shipped to me along with the devices. Functionalities and individual devices were described and registered through a website made for the experiment, where I recorded the IP and MAC addresses for each device I installed. For the procedure, I first collected packet captures while installing the devices to see how they interact with different domains during their initial setup. After this, I made sure all the devices were connected once more before starting another packet capture, this time to analyze traffic while the devices were idle. This was to understand how the smart devices behaved while not in use. Although I'm not done with collecting data, the next step for the experiment is to collect packet captures from using individual features identified for each device, both without rules and with rules generated by SmartWall. After collecting these packet captures, we hope to better understand the impact of the generated firewall rules, specifically in improving the security while preserving the functionality of the smart devices used. Thank you. I will now be taking questions.